The type of the bonding tells us about the structure of the substance, and the chemical bonding and the structure tells us about the properties, physical and chemical properties of the substance. And from the properties, we are able to find out the use of or utility of the substance. So my present topic is that how the chemical bonding lead us towards the structure of the substance. Right now we have discussed about that the ionic bonding is formed by the positive and negative ions. The force of attraction between the positive and negative ions is the base of the ionic bonding. And these positive and negative ions are closely attached together. The ionic crystals are like the three-dimensional network in which the positive and negative ions are arranged regularly, and the positive and negative ions are strongly attracted each other. The positive and negative ions are held strongly and they are attracting each other so strongly, and it is arranged in a very regular pattern in a very three-dimensional way. So you see that the negative, positive, negative, where negative is for chlorine and the positive is for sodium ion, and in this way the chloride ion and the sodium ions, they are closely attached together in the form of like a cluster. They are attached together. So the forces of attraction are very large, very big. So it is a giant ionic structure. So the structure of the ionic compound we call the giant ionic structure, in which the forces of attraction are very large and positive, negative are attached with one another with the strong forces of attraction. Like the positive sodium ion and chloride negative ions, they are closely attached together. And this is a reason that because the forces of attraction are very strong, this is a reason that at room temperature ionic compounds are in the solid form, and because the forces of attraction are very strong, this is a reason that ionic compounds are very hard, and they are closely packed together. And when they are closely packed together, so in the given volume, a lot of positive and negative ions are packed together and they are systematically arranged so the density will be very high. And because they are closely packed together, and this is a reason that the melting point will be very high. If you want to melt it, we have to break the sodium and chloride, one ion sodium chloride, second ion sodium chloride, and it's NaCl, that forces of attraction are very strong and we have to break these forces of attraction. And because the forces of attraction are very strong, therefore we need a very large amount of energy. Similarly, the ionic compounds are not volatile. Volatile substances are those substances which can be converted into vapors at room temperature. Because these forces of attraction are very strong, so at room temperature these cannot be converted into vapors. So ionic compounds are not volatile. And some of the ionic compounds have very high melting point, like magnesium oxide and aluminum oxide. Their forces of attraction are very strong and they can sustain very high temperature, they can tolerate very high temperature. So these are used as an inner lining of the furnaces, and such a material which can tolerate high temperature, sustain high temperature, and can be used as the inner lining in the furnace. These type of the material are called refractory material. So ionic compounds can be used as a refractory material, and all these properties are depending upon its structure and the type of the bonding, that is the positive negative ions, and they are arranged in a regular way and they are attracting each other very strongly. And if I would like to illustrate how they are melted, this is the positive negative sodium chloride ions. This is a crystal of NaCl, and we need a very high temperature. 808 degrees Celsius is required to melt it, and the positive negative ions are slightly separated from one another, you can see, and this is a molten NaCl. But because the forces of attraction are very strong, so we have to apply a large amount of energy, therefore we need a very high temperature. So 808 degrees Celsius is the required temperature to melt sodium chloride. And still they are attracting each other in the liquid form. To convert it into vapors, we need to have the boiling point, and 1413 degrees Celsius is required. The required temperature. When we have this temperature, the ions will go further away. You see, they will go more away from one another, and then it can be boiled. So the melting point and boiling point are very high because the forces of attraction in case of the ionic compounds are very high, and the structure is that they are arranged very closely in a very systematic way, and in the crystalline form the positive negative ions attract each other very strongly, and the structure is the giant ionic structure. So the ionic compounds can be brittle because when you hammer it, when you apply some force on it, this positive will slide, and the positive will come next to positive and negative will come next to negative, and in this way they will repel each other. Due to repulsion, they will become brittle, they will be broken into pieces, and they cannot be bent, and they are brittle, and they will turn themselves into pieces. When ionic compound is dissolved in water, so ionic compounds are soluble in water. The reason is that the ionic compounds and the positive and negative ions, and water is also having a charge on them in which oxygen is negatively charged and hydrogens are slightly positive charge. So the ionic compounds, on the edge of they are not much surrounded by the positive negative ions, and the water negative and oxygen will attract the Na positive, and Na positive will be attracted by water. The oxygen part of the water will attract it. Similarly, the second water molecule, oxygen, will also attract it. So Na positive will be attracted by the water. So this Na positive will go with the water, and this place is empty because it is apart from the sodium chloride ions. It has gone away from sodium chloride ionic and crystalline part. So the Na positive is surrounded by the water molecule. In this way, Na positive is dissolved in water. And similarly, the Cl negative part will be taken away by H positive because these hydrogens are positive. So these hydrogen will attract the Cl negative, and similarly all the sodium chloride will be dissolved in water. So ionic compounds are highly soluble in water. The reason is that the water is charged, oxygen is negative and hydrogens are positive, and NaCl crystal is also having a charge on it. In this way, they will interact with each other. Oxygen negative will attract Na positive, and hydrogen positive will attract Na positive. So if the solvent water is having a charge on it, and the NaCl, the solid, is having a charge on it, they are soluble. So some solvent which is having a charge on it, we call it polar, and Na positive Cl negative is also having a charge on it, so this is also called polar. So polar dissolves in polar, like dissolves like, birds of a feather flock together. So how they are soluble.